So today we discuss one of the most important topics of OOPS, that is the third principle, which is inheritance. Now this is one of the most important topics beginning in Java. So what inheritance really means is reusability of code. So suppose we have a class of players and we can define some code or some properties which are specific to players, and we can define a class which is specific to a particular game. So some characteristics of players will be defined here shall automatically be inherited into this football, and similarly we can define some specific property of players which play cricket, but however they will inherit the general characteristics of type player. So when we say inheritance has happened, we say suppose a class A which is inherited by class B. So we say that everything of class A is now part of class B. So making it part of B means that now B can access everything of A through its own object. So if A has a method say show, then we can create an object of class B, say B1, and I can call this method show as if this show was defined within the class B itself. So this is where inheritance comes in. Now we have the entire behavior as well as the properties of A extend into class B, and we call A as a superclass and class B as a subclass. So generally we say inheritance has happened when the object of subclass, when the subclass object, this is a subclass object, the total, this is a subclass object. When it contains the superclass object, this is a superclass object, we say that inheritance has occurred. So when inheritance happens, everything which is public, everything which is protected, everything which is package defined in class A becomes a part of B. So B can access anything of A as its own content. So this leads us to a very highly reusability of code and also a more clarity of code. Suppose we have a class with 10 methods. So what we can do is break up the code and define 5 methods in one class, and 5 we can define in a subclass inherited from the superclass. Say I define 5 methods in class A and 5 methods I define in class B, and I can say B extends A, and all the entire 10 methods are now part of B. So instead of cramming all the code within the class B, I have made it more readable, I have made it more usable, reusable, because the 5 methods that are defined in A might come in handy for somebody else who might want to use the same in his class, and he can extend A and make them available to his own class. So what exactly is available in inheritance in Java is, it is a single line inheritance, means we can have A extended by B and B can be extended by C, and in this way we can have a single line inheritance. We can have another line going like D, like E, but again this is a single line inheritance. What we cannot have in this case is that we cannot have A and B both extending into C at the same time. So this is what we call as multiple inheritance. This we are not having in Java for reasons we'll discuss. Now let us programmatically see how inheritance is working. So we'll have a class A. a class B that extends A. I'll create a method show here, and I can say I can even have a variable X here. So now in now what I do here is, in main I'll create an object of class B. Class B in itself has nothing declared within itself, and I can say b1 dot x is equal to 40 or 50, and I can print out b1 dot show. Now there is no show declared within B, but because of inheritance, this x, this show now becomes a part of B, and I can access everything of A by creating an object of class B. So just have a show of this. So it says in show of A. So this is just a brief demonstration of the power of inheritance. Now I can declare any method here itself. So this further extends the class A. Now in addition to the methods inherited from A, now B has additional methods that it has declared on its own, which is show1. So in this way B can extend the behavior of A by declaring methods of its own. So now let us see what we mean by when we said that we say inheritance has happened when the subclass object, it actually contains the superclass object. So this is the main concept of inheritance, without which it cannot work. So now suppose I say I have a variable here, say int y is equal to x, and I create an object of class B. So when I create an object of class B, in fact what I am doing is I am giving memory to variable y. Now giving memory to variable y means bringing x into picture. Now bringing x into picture means you need to have object of class A into picture, because if x is not into picture, then y cannot be provided a value, and x can only come into picture when you have an object of class A in picture, because it is an instance variable of class A. Without an object of class A, we cannot have x into in memory. So this is what the circle is. We require y to be in picture as soon as you create an object of class B, but y depends upon x which depends upon an object of class A. However, as we can see, I'll just try to print. I have created an object of class B and I am printing the value of y. So there is no error, and I am getting a value of y which is 10, which is as per the value of x. X was defined to be 10. But in this entire circle, we haven't created any object of class A. So how this has all worked out? Without an object of class A, x cannot be there, and without x, this y cannot be there. So what exactly is the circle here is, now whenever we have a superclass like A which does not have any constructor, system declares a default constructor. So this is the structure of a default constructor that it creates in class A. Now what happens in class B? Now as B is a subclass, so there is also a default constructor, but in this case the default constructor has a default statement which is super. Now this super is equal to the superclass constructor, and this is what ensures that the superclass object A is in picture before the subclass object B is created. So this is what ensures that this X is in picture, or everything of superclass is in picture before the object of subclass it comes into picture. So we can really see that this is happening in case I remove this constructor. But I do have a constructor in the superclass and I pass a object int variable to it. Now as you can see, there is an error coming which says that super constructor A default is undefined, so you must define an explicit constructor. Now the reason is, now when there is no constructor in class B, the system is creating something of this kind. Now this is trying to call the default constructor of class A, which now is not there because we have constructed our own constructor, and when we have made a constructor of our own, the default constructor is never there. So system is not able to construct an object of superclass before the subclass object, and the entire circle stops. In case I declare any default constructor here, the things start working. As you can see, the error has gone and everything is fine now. So you can see this is working. As soon as I remove this constructor, immediately the problem pops up, because now the system call to the superclass constructor is not getting completed. So in case we do not have a default constructor in the superclass, we'll have to create a subclass constructor and give a call to the superclass constructor explicitly. Now since the superclass constructor has an int value passed to it, I'll have to pass any int value to it to complete the invocation of the superclass constructor. Now the superclass constructor call is complete and there is absolutely no problem in the program, and I can again run and show you the output. Now since we are calling this constructor, I can do is I can initialize this X through this. So now we have 5 coming up, because now through the constructor I have passed X the value of 5, and this 5 is then passed to Y, and when we print Y you get a value of 5. So while devising any inheritance program, we must ensure that the constructor call is complete so that the inheritance procedure is as per the definition. So only thing remembering while inheriting a class is that the superclass object is complete before the subclass object, and second condition to this is that I cannot, and this call to the superclass constructor has to be the first statement. Suppose I add any print statement before this, so it is not accepting this statement. It says the constructor call must be the first statement. So I can write this statement within the constructor, but has to be after the super call. And similarly I can put down a statement here after this. We can just write constructor of B call. So you see the order is reverse. First the constructor of A is called, and then the constructor of B is called. So this is the main aspect of inheritance, that whenever we are extending a class, we must ensure that the call to the superclass constructor is properly arranged. Otherwise the program shall never compile and it will always show an error uh, that the explicit call to the superclass constructor is not complete. So I'll just summarize this entire thing. So one is, inheritance means that everything from superclass is inherited into subclass except for the private stuff, because it has the visibility access problem. Then we have that default constructor is there in superclass, but the default constructor in subclass, it has a super call by default to the default superclass constructor. So rather than putting, I'll just put on in short. In case we do not create any constructor in the superclass, there is a default constructor in the superclass, whereas for a subclass there is also a default constructor, but the only difference is that there is a super call to the superclass constructor. Another point worth remembering here is that even though I have a default constructor in the superclass, say I have a default constructor in the superclass and still I need a constructor in the subclass, I can create one. I can still omit this superclass call because this default superclass call is included by the system within the subclass constructor. So system will itself write this code even if I am not writing it. So I am leaving this code, and through the output we can see that the B class constructor is automatically calling the default constructor of A class. Well, this we can see the default constructor is being called, then we have constructor of B called, and then we have the value initialization. So this call to the superclass constructor will be inserted by the system, but it can only insert a default constructor call. In case it is not there, then we need to explicitly make a call to the superclass constructor, and that would set the entire thing working. So we'll continue with inheritance in our next lecture.